Everyone. I hope you enjoyed your break. It is my pleasure at this point to, if I can organize things, to introduce Alyssa Toy. Alyssa is an experienced data scientist currently building and deploying predictive and prescriptive analytics solutions in the consumer goods industry. Experienced in building analytics solutions for business functions such as sourcing, supply chain, sales, and marketing in multiple industries. So Alyssa, you can go ahead and take the reins.
Awesome. I'm going to share my screen. Let me know if you can see it. Good, awesome. Well, so I am Alyssa Toy. I am a lead data scientist at General Mills. I've been with General Mills for about 1.5 years, now working in the marketing, data, and analytics space. Today I want to talk to you about deploying end-to-end production workflows in R. We have both R and Python users on our team. We're kind of evenly split now, but we do have RStudio Connect, so I will be focusing most of my production workflows in RStudio Connect. But at the end, I'll give you some options to do it in an open source fashion if you don't have that available to you. So I've worked at a few different companies, and each team has kind of managed their workflows in different ways. The last kind of few companies I've worked at had this kind of old way of working where we're importing data using, a package in RStudio. We're outputting our clean data into a database. We're then reading in to, maybe another package in RStudio, and we're training our model. We're building our features in another package and outputting all of the predictions as another table. And then we're reading in all of that, trained predicted table into a Tableau or Power BI and Shiny. They were either run locally or they were scheduled on a Linux server. But, it felt kind of clunky and it wasn't super intuitive. It was really buggy, kind of hard to collaborate. Jobs failed for unknown reasons because of something that went on the Linux server. So there was lots of different things that was not working so great. And when I joined General Mills, we finally had an RStudio Connect server, and we spent some time working on production workflows. I went to the RStudio conference in January, and they talked about end-to-end production workflows and Plumber and Pins and these packages that I hadn't used before. And so I started to kind of work with this and kind of compiled a bunch of different resources together to show you kind of this new way of working. So why something new? I wanted something that was really easy to collaborate with the team members on my team. I wanted something that was really easy to schedule and maintain. The last thing you want to do is spend hours trying to get something to run on a schedule when you've got all of these different priorities that you're juggling. I wanted something that was really accessible to business partners, because as we're surfacing our data science work, we want to make sure that it's being used and it's easy to use. And I wanted something that had really good security. I didn't want to kind of fumble around with my own LDAP security. We had done that in the past at another company, and I wanted something that was just a click of a button where I could just say, these are the people that can see this, and these are the only ones who can. So this new way of working, one big change I thought in this workflow is that we're importing data and we're training our model using R Markdown. I always thought that R Markdown was just for reporting, but it's not. So it's a really good way to, schedule your jobs and modularize and code chunk out your production workflows. So this new way, we're importing data using R Markdown. We're saving out the clean data or any type of data sets that we need in either, we're using a data lake at General Mills, but you could use a database, you could use pins depending on how large your data set is. Then you're training your model in our Markdown and saving out that model object as a pin. And I'll talk about all of these different modules in the presentation so you know how it all works together, but just to get a high level. You're then serving up your model using Plumber, and then sharing out your predictions either in R Markdown or Shiny. And this is all hosted on RStudio Connect. So it all works together. You'll see this slide a few times as I'm kind of working through each of the different modules. I'll go through R Markdown, Pins, Plumber, and Shiny. So R Markdown, I'm sure you guys have seen a couple of presentations on this already, but just a quick overview is that it's just a really flexible framework for data science. You can execute and save code, generate static and dynamic reports. So if you've got a template and you want to run, you know, a report for each region of the US, or, you know, for us, we've got an R Markdown template for each brand. So we've got one for Cheerios and one for Cinnamon Toast Crunch. It's really easy to have one template and then swap out different parameters. So you can execute code chunks, display text. They're really flexible. They're supported for SQL, R, and Python, and they're reproducible, really easy to track and get, and easy to deploy. So again, here, we're importing our data in R Markdown, and then we're also training our model in R Markdown. And I will show you a quick example. So this is I'm going to show you an end-to-end workflow. It is predicting the house prices of the King County. It's a data set on Kaggle, but I just wanted to show a simple example so that you can walk through each of the different steps. So in this first R Markdown, we're just ingesting our data. We're loading our libraries. I'm connecting to my RS Connect pin board, and I'll talk about pins in the next section. But you could use your connections to a database, or you could connect to a different model API to get your data on a recurring basis. I'm just getting the data as a CSV right now, just looking at the summary, checking for missing data or checking for duplicate values. Everything looked good, so I'm just going to start prepping my data. I'm going to clean it using just selecting the columns that I need. I'm going to filter out some outliers, and then I'm going to convert some data types. Once that's done, I'm splitting my data into training and test. And then I'm just going to pin my data to the RStudio Connect board. Now, you can have this scheduled on RStudio Connect on daily, monthly, weekly basis, whatever you choose, so that you're always getting the new data and you're always pushing that data out on a recurring basis. Now for my model, it looks pretty similar. Getting my libraries, I am connecting to my pins board, and then I'm getting the pin that I saved out for my training data. So I'm always getting the newest version. I'm just training a quick linear regression model, predicting price, given the number of bedrooms, bathrooms, square footage, and floors. And then I am just looking at the model. So you can do all of your feature engineering, parameter tuning, everything in this script, and you can save it out, however often that you want to save out your model, your new model. So I'm also pinning that model as a model object. So some best practices for R Markdown to make it as functional, reproducible, productionalized as possible, using parameters or dynamic variables rather than any hard-coded variables, making sure you name your code chunks and modularize your code chunks, refrain from using like plain text passwords or unused packages, code, or data frames. It's really important to use relative file paths, especially when you're deploying something within RStudio Connect or you're putting it on a Linux server, so that your code always knows where to find certain files. Using a linter or a styler package to kind of reformat your code. And then it's also really important to use test that to incorporate unit tests within your functions and your code, making sure that your input data is what you expect it to be, and then what your output data is what you expect it to be. And then finally, like, convert your project to a package. The next step is pins. I'm really excited about pins. It is something that has been really useful already. So you can use this package to pin remote resources locally. You can work offline, cache results. You can share your resources in different folders. We share it on RStudio Connect. You could share it on GitHub. But basically, you just take an art object, a data frame, a model object, and you pin it to a board. So it's really good for collaboration. Instead of emailing objects or saving it to a database, you just share the name of the board and the pin name, and you can work collaboratively with your team. And the users will always get the newest version. So if you're, saving out a pin on a recurring basis within our Markdown, that will always be overwritten, and you can save it that way. So it's really simple to use. If you have an object, you just do a pin with the data frame or model object name, and then the board that you want to save it to. It could be RStudio Connect, GitHub, Azure, GCP. I think they're working on expanding this a lot. And then you also just give your pin a name. And then just to get it, you just do a pin_get to get the pin. So as you can see here, I'm going to use an example where you saw me import our data. I'm going to output that data as a pin. I'm also training the model, and I'm going to save it as the model object as a pin as well. So I cleaned my data, I split it out into train and test. I want to save both the train and test as a pin. So what I'm doing is I named that data frame train. I'm giving it a pin name called house train data, and then I'm giving it a description just so that people know what it is when they go into RStudio Connect. And then I'm just pointing it to the board. It's really simple. Same thing for the model object, just pinning the model, giving it a name, description, and what board I'm pointing it to. Really quick, if I could save anything, but if I wanted to get it back, I would just do a pin get, name of the pin, and the board. One of the things that I really like about pins is that it's super easy to share and lock down in security. So if I show you in RStudio Connect, I saved out that empty cars data, and you can download it as a CSV from RStudio Connect. You can get that pin using R or Python, and then you can also preview and see, oh, okay, what is this? What do I have access to? What pins or what model objects or data frames do I have access to in RStudio Connect? And then I can also, put more information about my pin. I can lock it down to see, who can see this pin. And so it's really nice to be able to use it that way. So some best practices for pins is that it's not a database replacement. If you're cleaning data and you are working with a lot of data and you're trying to incorporate pins, or you're trying to incorporate some type of data pipeline, pins is not really the best place for that. But pins are smaller; they're a gigabyte or less. Smaller if possible. But they're reused, they're recreated. You want it to be current, so you always want the newest version when you go to RStudio Connect. You want it to be shareable, plus you can secure them. But they're really good for objects that are computationally expensive. And maybe like to cache results. Maybe you're going to the cabin and you want to work with something offline. It's really great. And I think they're really good for model objects because it's simple to update the model independently from the R Markdown or the API that serves the model predictions. And then it's just easy for us to save out that model object. We used Artifactory at General Mills as well, and I just find that using a pin is a little bit more simple to use. So a very quick summary of Plumber. I've got some links at the end of the slides where you can, deep dive into Plumber, but I just want to show you how everything works together. So you can deploy machine learning models as a RESTful API built in R. It's really flexible. It's just a couple lines of code around a function to deploy a Plumber API, but you can log details about who's requesting information from the API. You can get details about responses. You can also call Plumber APIs from other languages. So as you can see in that picture on the left, we've got a Plumber API. It could have been in R code or Python code. It's deployed on RStudio Connect. And then we've got all of those options on the left side that can all connect and get responses from that Plumber API. So it could be a Shiny application, an R Markdown report, another API, Python, or other languages or applications. So if you've got, say, a .NET application that needs to get responses from a Plumber API, you're able to connect that two together. And it's really simple. I will show you a quick example where we're trying to just return the sum of two numbers. So you call your library and you just return the sum of two numbers. So you define your parameter A and your parameter B, which are the two numbers to add. And then you just do an at post to get the sum of those two numbers. So very quick function. You can run this API. And it looks like this. So you just do this. Let's try it out. See if it can add 2 plus 2. And then we get the response. So we've got our, goes to the function and gets the answer. So number 4, it's correct. So I want to show you kind of where we're at. We've imported our data. We've trained our model. We've got our model object. Now I want to use that model object to create a real-time model API. So here we are, loading my libraries that I need. I'm registering my pins board so I can get that model object. This is where the board is. This is the server. This is the key. So another good tip for using RStudio Connect with Plumber and Shiny, if you want to connect to a pin that you've selected, you have to create an API key within RStudio Connect and then set it as an environment variable. So I've already done that. I've got my Connect API key. And then I just do a model pin get, and then this is the name of my pin and this is the board. So it's got the model already in there. I'm now creating my function. So I want to return the predicted house price for whatever inputs that my user puts in. So I've got my 4 parameters for bedrooms, bathrooms, square footage, and floors, and I want to get the prediction back. So what I'm doing is I'm just taking those 4 inputs. I am creating a new data frame with those inputs, and then I'm just doing a predict. This is our model, and this is our new data frame. So let's see here. So we can just do this. We can try it out. Got 2 floors, maybe 1,500 square feet, 2 bathrooms, and 3 bedrooms. So our model is predicting that house to be about $382,000. Let's see if I can close this. And so why are we connecting Plumber and Shiny? Well, Plumber is really great to host model APIs and get predictions. It's really good when you are working with your team and maybe you're trying out and testing your model to see what different types of predictions you're getting, but it's not really a great thing to give to your business partners. You want maybe to visualize your predictions or let your business users play around with things. So Shiny is more intended for that human consumption. Also, Shiny will scale really well if the data is not duplicated in memory for each user. So if the data is housed in pins and Plumber, and it's all separated from that app, so you're not slowing down your application. Because if the underlying data is really large, it's going to just make your Shiny app not very performant. And the nice thing is that all of these different pieces are kind of separated from each other. So if you update your ingest data, you're not breaking your whole workflow. If you are updating your API, you're not breaking your Shiny application. So Shiny, I know you guys have seen a couple presentations on this already, but it's a web application framework in R that allows you to turn your data into a web application. The UI controls the layout and appearance, and the server script contains the code needed to build the app. So the servers piece is where we are hitting our Plumber API for a request and getting a response. You can connect your Shiny to Plumber to get predictions from your model to share with your business partners, or you could create it for an application within your team if you want to monitor model performance. So we're at the last step. We've imported our data, we've trained our model, we've served our model in Plumber, and now we're ready to share our predictions. So I'm going to use Shiny. And I'll show you the app first, and then I'll kind of show you the underworkings there. So this is just a quick one. We're using a Shiny theme called Flatly. This is just one if we want to do our user inputs. So this looks like a little prettier for your business partners. They can go in and say, I wonder how much this is. Maybe 2 floors here. And we hit submit. It's going to hit the Plumber API and get the response, and this is the predicted house price. So you could use this in a variety of different ways. You could use it to do scenario planning. So maybe you have a model that predicts something, or you can do, like, if you're trying to predict how well a promotion is going to do, depending on like different dates or different products. It's really easy for your business partners to use this way. You could also do fun things with it. I've got a leaflet map, so you can look and see, maybe I want to live here. It's got 4 bedrooms, 4 baths, 4,000 square feet, and 2 floors. I'm just going to click on it, and it's going to use this input from the latitude and longitude to hit the Plumber API, send the inputs, and get the response for the predicted house price here. So it's about $1.1 million, a bit out of my price range, but just this fun way to show that it can be used in a variety of ways. So I've got my Shiny app here. I've got my inputs, and I've got my map. But I'll show you the server piece because that's the fun piece. So to get our predictions, we just do a quick HTTR get. I'm pointing it to my Plumber API that's deployed on RStudio Connect. And then I'm sending a list of inputs from the app to the Plumber API. So I do a query, and I'm getting all of the inputs from the bedrooms, bathrooms, square footage, and floors. And then I am connecting the API key that I created in RS Connect. I'm getting the content from the API call. When you do the API call, it'll give you a ton of information, but we just want the response. So I'm getting that, and I'm converting it to a table, and then I'm displaying it as a data frame in data table. So you can do this in an open source way too. You could have a cron job that runs your R markdowns for importing and training your model. You can use a database or a pins board like GitHub or GCP or Azure, depending on what you're using, to get your data outputs in your model objects. You can serve your Plumber API on like DigitalOcean or Docker, and then you can share your predictions with Shiny using Shiny Server. So one thing is that you should remember to use test that in your workflows. As you're updating different pieces, while you're not breaking the entire workflow, we want to make sure it works as expected. So it's really good to use unit tests throughout your entire workflow. And finally, we are hiring at General Mills. So we are, it's a really exciting time to be a part of data analytics at General Mills right now. And we've got a variety of different tech jobs. So visit careers.generalmills.com/data tech jobs to learn more. And here are some helpful links, just an overview of our markdown pins, Plumber, Shiny, test that, and then another good examples of putting R in production. Thank you.
Great. Alyssa, that was an awesome presentation. Thanks so much. Anyone who has questions, feel free to add them to the chat now. It looks like we have one question from Jane Nolan. She asks, how does using pins compare to just using a GitHub repo to collaborate?
I think it's really good to use pins mostly for model objects and data frames. You don't want to save out large data files on GitHub, so it's easier to pin that to a pin board, and that way they can get it that way.
Great, thanks. Are there any other questions? Anyone have anything to add to the chat? All right, I don't see any other questions, so I think we're going to take another short break. I believe we're back at 10:35 for the next presenters. So I believe we get some nice Minnesota music from Lindsay Dietz for the next 7 minutes or so.
Thanks, guys.
Thank you.